Welcome back to the channel. Today we're going to be talking about spot rates versus forward rates, how to calculate one from the other and tell the difference. So first I'm going to go and get some spot rates from the treasury.gov website. This is from the U.S. Department of the Treasury. This is listing the daily Treasury par yield curves for my current month here. And I'm going to pick the latest day and copy this row over into Excel. So Control C, Control V puts it into Excel. And let me expand B. Oh, let me go back and copy the headers for these columns as well. There we go. So now we have actual data on, we'll call these the spot rates. Technically, a spot rate is the rate on a zero coupon bond, and these Treasury securities are not all zero couponed. These first couple, the first five, have terms of less than a year and they don't pay any coupons. The 1 year plus bonds pay a coupon every 6 months. So these rates are different than they would be under a pure zero coupon structure, but we're just going to use them. We can always go back and adjust to remove the coupon if we need to in the future, but for now, this is, for the sake of example, pretty good. So here's our spot rates. The first thing I'm going to do is create the monthly version of those rates. And I'll put it into percent as well. So that's equal to this divided by 100 divided by 12. So there's our monthly spot rate. Copy that over. Let's make it a percentage. Give it a couple decimal points. Great. So that's our monthly spot rate. And the goal here is to go from spot rate to forward rate. Another thing I'm going to need for that is a kind of a time row, so I can figure out exactly how much time is passing at each point in the yield curve here. And I'm going to just do this in months. It's going to make it easier to do this in months. 1 month, 2, 3, 4, 6, 12, 24, 36, 60, 84, 120, 240, 360 months. Okay, so here's our monthly rate. Here's our time in months. Before we calculate the forward rate, we're going to accumulate the spot rates on a monthly basis up to the time of termination. And these are called the wealth factors sometimes. Or sometimes they're called the accumulation factors, or I've seen them called like accumulated interest. All these factors are really saying is how much money, if you invested $1 today, would you end up with after 1 month, after 2 months, after 3 months, 6, 12, 24, etc., based on this spot curve. That's all it is. So the formula for that is going to be 1 plus the monthly percent to the amount of time in months. Simple, right? Make that a percentage. Copy and paste it so I get the format copied over. So now we have the actual wealth factor. So if I invest $1 today, in 2 months I'll have 101% of that dollar. Pretty bad. And then if I wanted to do it for 12 months, now I have a 6% gain. That's pretty good. That 6% is almost close to that 5. 4, 5 makes sense. Okay, looking pretty good. And as you get further down the term structure, the rate that you get is generally lower, which is not super duper usual for these things. Usually the rate at the end of the term is going to be higher because you have to wait 30 years to get all the money back, right? So usually they pay you more for that, but we're in a weird economic place right now. They're not really doing that. So anyway, the forward rate at each point in the curve is equal to the change in these wealth factors. That's it. That's totally it. Except at the first point in the curve, it's really just equal to the same as the spot rate because there's no rates before it. So that is the forward rate. And the idea of the forward rate is that if you're standing now at time 0, what rate would you have to pay in 1 month to get a security that's 2 months old, 2 months hence? I'll try to say that again a different way. It's kind of saying like, well, if I wanted to get a 2 month security, but I don't want to buy it for a month, I want to wait a month and then buy it, what rate could I pay today to get that security today? That weird, like, I'll buy it in a month security, but I want it to mature in 2 months security. And these securities do actually exist. You can go to the forward market, and they're useful for a lot of hedging work. Especially in my industry, we do a lot of hedging for annuity products and things like that, and we want to hedge against interest rate risk. You can buy a swaption, you can buy an option on interest rates, but it's a lot easier to buy a forward contract. And there's so many standard forward contracts that they're actually called a different thing. You can get a futures contract, which is just a standardized version, commoditized version of a forward agreement, which is doing the rating that we're going to see here in a second. So all we're doing is taking the difference. So this divided by that minus 1. There, that's your forward rate. And this is a pretty short in the term structure here, and the rates are pretty close together. So the forward rate is very close to the spot rate on a monthly percent basis. And that's all there is to it. These represent the rates you'd have to pay today to buy a contract that starts in the future and lasts up until the term specified at these dates up top. How do we check that we have the right forward rates? Well, what we do is we calculate the discount factor that we would use on both a spot basis and a forward basis and see if they're the same. And I'll just show how that's done as a way of explanation. So the discount factor using spots is just equal to 1 plus the spot rate at time t, whatever t is, to the negative, negative t. So we discount that back. We get a discount factor of this. And if we drag that over, we get this series of discount factors here. So it's just going from spot rate, 1 plus spot rate divided by, or 1 divided by 1 plus spot rate to the power of whatever, and that's the value of money today at that term in the future. So would you rather have 24 cents in the future or $1 today? You'd be indifferent to that in theory. The discount factor using forwards is done in a totally different way. What you do is you start at 1 times 0, your discount factor is 1, and then you take the previous value of the discount factor on the term rate, on the term curve, and you multiply it by 1 divided by 1 plus the forward rate. And you'll get the same values. There you go. There's no difference, but the formula is different, and you arrive at the same answer. So there is only one answer, but you can get it a few different ways. The forward rates are great for this. If you're doing a calculation that's going on for many years and you're doing it monthly, let's say, if I'm doing a 50-year calculation, let's say I'm evaluating some insurance liabilities, if I wanted to do it using spot rates and get the discount curve, I would have to take something to the negative 600 power, which might blow up my computer. It's pretty computationally intensive sometimes, so you don't want to do that. It's a lot easier for a computer to do this. And so many programs and pieces of software will take whatever spot rates you give them, and they will convert them to forward rates and then get their discount curves using those forward rates. It's just better for a computer. It's a lot easier to handle it. The only problem with doing that is if there's a big jump in a spot rate across one of these terms, it can blow up the forward rate calculation. If this spot rate here was, let's say, 20, now you see you have a negative forward rate, which computers don't like. Anyone that's looking deeply enough into the numbers won't like. The discount factor will be the same as those used under spot rates, but there would be a created kind of blip in the forward rate curve whenever there's a shock in a spot rate, and it causes problems across the industry. So that's what you want to kind of avoid. Usually the world doesn't have big jumps like this, but if you are constructing a spot rate curve, let's say you want to create a curve that's 100 years long, you might accidentally put a jump in somewhere that messes up a forward rate, creates a negative, blows up your program, and you'll never understand why unless you do an exercise like this and go from spot to forward and see that there is a jump in there. So that's kind of an introduction to forward rates, what they are, how to calculate them, and how to verify them. Thank you.